Hello. In the next video that I'm going to show, I will try to explain how to implement and continue deployment on Kubernetes using the split cloud pipeline. Before starting, I will explain the application architected quickly. The application manages the needs of the dance school, customer, classroom configuration, assignment of customer to different activities like yoga, funky, and student control, etc. The system is implemented following the pattern for microservice architecture and will be deployed over Kubernetes. As we can see in the figure, the functional microservices that are in purple color. The customer's color manages customer information, classroom school manages the configuration of the classroom, type of class, number of students in the classroom, etc. Class customer school and class customer view school control the assignment of customer to different activities and class, and both use the event sourcing and cost patterns. Class customer view school stores information in MongoDB and is communicated with class customer school through Kafka. Class customer school and class customer view school use Srping cloud contract for the smoke tests that we will discuss later. On the other hand, the microservices in blue color are the infrastructure services, discovery services, process service for security, and the system configuration services that get the configuration information of GitHub. Another functional microservice is the web service that communicates out of the box with the security service through OAuth. The token is propagated through by all other microservices. As we can see in the figure, all the functional and infrastructure services except the security service are within Kubernetes. We will use the Srping cloud pipeline to deploy these services within Kubernetes. In this video, we will see how to do all this, and we will deploy the class customer view services as an example of deployment.
Srping cloud pipelines provide script configuration and convention for automatic deployment pipeline creation for Jenkins and concurs with Cloud Foundry or Kubernetes. We support YAML language, PHP, and Node 8 and .NET 2. In this project, we use deployment for Kubernetes. Each repository can be treated as a template for the pipeline. The flow is shown in the image. It's a build environment is a machine where the building of the application takes place. It's continuous integration or continuous delivery tool worker in order to run some unit test. The test is an environment where you can deploy an application to test it. It does not resemble production because we can not be sure of this state, which application is deployed running in the which version. It can be used by multiple teams at the same time in order to run smoke tests. The stack is an environment that does resemble production. Most likely, applications are deployed there is version that correspond to those deployed to production. Typically, standard database holds production data. In order to run some perform and user acceptance tests. The last one is the product is the production environment where we can test application to be deployed for our customer. Srping cloud pipeline has several projects, but the two that we will use are script creation of common deployment pipeline, and Jenkins. This project contains setup for Jenkins that create jobs and pipelines by Jenkins job DSL or Jenkins file for the project. The pipeline and jobs use the script defined in cloud pipeline script repository. All the work on the pipeline will be done through the Dance School Cloud Pipeline project, which will be a clone of the Jenkins project. In this project, we modify everything that is necessary, but always in separate files to be able to update the original files at any time. For me, there are three very interesting features of Spring Cloud Pipeline. The first is that Cloud Pipeline uses bash script. This makes you have all the power of the bash to program the action of the pipeline. The second one is that integrates with a Spring Cloud contract that allows testing using contracts and allows creating tests for a real communication between services. The third feature is that allows a complete customization so the flow asks the action to be executed in the pipeline. The customization is very important because it has allowed me to incorporate new infrastructure service into my pipeline. As we commented at the beginning, each of the functionality services use the infrastructure service such as configuration, source, history, etc. Spring Cloud Pipeline only supports the deployment of Eureka as an infrastructure service. Thanks to the power to customize my pipeline, I have been able to add the new functionality to deploy these infrastructure services. The steps is very simple and to customize is very simple. First, I have created a file called pipeline.ks. In this file, I will override the code that I need to add a new functionality. In my case, in the deploy service function, I add the code need to add my new infrastructure service. As we can see, the Spring Cloud Pipeline identifies each one with a name, for example, Eureka. On the other hand, instead of this, I have called to my deployment service with the name infrastructure. Why? Because all of them are deployed in the same way. The only thing that I differ is the Kubernetes configuration file that I identify is with the name of the service name. As an example, we can see the file where is configured the configuration service for Kubernetes. The variables between brackets identify parameters provided by Kubernetes. For example, the name of the application. The second to customer, we need to compress the custom script. In my case, inside the script folder. To compress the custom script, I have made an utility called buildCustomer. I execute the script and wait. As a last step, we must indicate to Spring Cloud Pipeline the location of my file with the customization. We will do this through an environment variable called additional script tools URL. Later, we will talk about the Docker file that will be responsible for setting up our environment to run the pipeline. As we have seen, adding new functionality to my pipeline is very easy. Next, we will talk about how we will configure our repository of each of our services so that the pipeline works. As we discussed in the introduction, we will focus on the class customer view services as an example to do that.
Before continuing to see how to configure the repositories of the services for the pipeline to work fine, we will explain how I have implemented the smoke test in one of the services, specifically in class customer view. In order to understand it better, let's look at the flow of one of the tests. In this test, we want to verify if class customer view performs the correct operation. Class customer view is a service that uses the course pattern. This service receives an event triggered by class customer. This event takes the information of client resisting in the classroom and the type of the activity to be done in the dances school. The service stores the aggregation information in MongoDB database. The smoke test must verify the how communication flow has been correct. In order to this work easier, we will use Spring Cloud Pipeline, that it will help us manage the flow of communication through contracts. This means that the message produced defines the message using DSL annotation. This message won't only help to pass the test of the producer, in my case, class customer. Also, it will serve as a base to pass the smoke test of the consumer, in my case, class customer view. Class customer staff runner emulates the producer of the message. Using a staff runner, avoid run all the services produced that communicate message as the services we want to test, in this case, customer view. The flow of the test will be the following. The first, class customer staff runner load all the contracts to have configured. In this case, the class customer that were generated by the services when was deployed as staff. Also, you can see the staff deployed in Artifactory environment. In this case, class customer staff. This staff is packaged in jar file. As we can see, the message is the following. It is triggered by a register event and it sent to Kafka queue called class customer event. In body, the message is configured. In the memory configuration of class customer view consumer, we specify the ID of the staff so that when class customer staff runner start, it loads this contract connecting to the Artifactory service. In class customer staff runner, you can see this staff runner ID environment variable, where the staff runner resides the ID of the staff, configured in the Maven configuration of class customer view services. The variable is getting by pipeline. The second in the flow, the pipeline runs the smoke test of class customer view. The smoke test triggers the event through the staff runner. The third, according to the contract definition, sends the event to the Kafka queue. The fourth, the class customer view services processes the message. The service saves the information into MongoDB. And finally, the smoke test verifies that the information stored in MongoDB is correct. For this test from Jenkins is connected to the service in Kubernetes through the URL that was provided by the pipeline. We can see a Spring Cloud pipeline and a Spring Cloud contract make our life easier.
Well, at this moment we are at the point of configuring the repositories for the pipeline to work. We will have to configure 4 files within of the repository. The first file is the Maven configuration upgrade. In this file, we must configure several properties: distribution management URL, Docker organization, Docker hub URL, distribution management repository. We must also configure the different profiles for the pipeline. Within the build profile, we will configure the option to create the Docker image. The system prop environment variable is very important because in this variable, the pipeline will inject the variables of pipeline that we need to make tests. Another important thing is to add the dependency Spring Boot starter actuator. The actuator make the health endpoint, so that the pipeline using the health endpoint to check that if the services are working. The second file will be the file that the pipeline uses to know what it has to do. The file is divided into different environments. In this case, test and state. In the case of state, we indicate which are the services that must be loaded together with himself. In this case, we indicate that we need Eureka configuration and the staff runner. Remind the letter for the smoke test. The last 2 files are used to configure Kubernetes. In the deployment file, we will indicate the deployment option in Kubernetes. In this case, we configure that the services has 1 replica. The pipeline gives us different variables between brackets such as the name of the services, organization of the Docker, etc. In the service file, we configure the necessary information so that the pipeline can access this service. For example, to know the service health, if we use Minikube, we must use node port in type. Once in what is necessary to configure the repository, we will launch the pipeline as sample for the class customer view microservices.
To start the environment to run the pipeline, we need, in my case, Jenkins, Artifactory, and Minikube. In a real environment, we can install it in a cloud. In my case, we will install everything in localhost. Spread Cloud Pipeline brings a series of scripts to install all tools locally. Before executing them, we will have to configure several files. So in the configuration settings file, we will configure the credentials so Artifactory as the Docker Hub. In the Jenkins pipeline.groovy file, we will configure the different default values for the Jenkins environment. One important variable is the repo with binaries for Apollo. In this variable, we will define the address so that to start running download the staff information. In my case, it will be this address, which is where Artifactory is installed using Docker. When these files are configured, we will execute the script to install through Jenkins as Artifactory. Now, we want to install the Jenkins and Artifactory locally using the Srping Cloud Pipeline tools. To execute the start script, I need to change the folder in the demo folder. If execute the start script, I need the start script needs the different parameters to run. The user and password JIT, the different information to Docker, etc. The start script launches the Docker file configuration. In this file, it describes all the orders necessary to install the Jenkins and Artifactory. In this Docker machine is installed Kuberete utility and all plugins that the Jenkins and Artifactory need to work. When finished the project, we can launch the Jenkins on browser. At the address localhost 8080, we will open the Jenkins page. Within the task, we have a code Jenkins pipeline keys zip. If we enter the configuration option, we have several parameters. The most important parameter is a repo. In a repo, we configure the repository with which we will work. We execute this task. This task will create other tasks to perform the repository deployment. The pipeline created will be composed of 4 stages, represented by 4 boxes. The first stage is build. In this stage, we are generating a version of the pipeline. We are running unit and integration tests. In this stage, publish the fast jar of the application into Artifactory. During this phase, we are executing Maven build using the Maven wrapper, in my case, or Relay. We are also tagging the repository. That way, in each subsequent step of the pipeline, we are able to receive the tagged version. The second stage is the test. Basically, in this stage, we launched the smoke tests. For them, the system reads the file code Cloud Pipeline and loads in Kuberete in the next step of the stake all the necessary services to do the test. In this case, Eureka, configuration, and the stuff runner. It will also launch the test for the compatibility of the APIs. In the third step is a stake. In this stake, it will launch the end-to-end test. And in the last one, it will deploy the microservice in production. Even we can perform a rollback if we have a problem. we execute this task. This task we create other tasks to perform the repository deployment. We execute the first stage of pipeline and let it work. Once the task is finished, we can verify in the repository the new version in tag. The next step will be test. If we see the log through console output, we can see that the pipeline uses the custom script. Also, we see that the pipeline reads the file called the cloud pipeline and load in the Kuberete in the namespace of stake all the services necessary to make the test. In this case, Eureka configuration and start running. As we can see the system through the configuration files of Kuberete, we launch the services and pipeline, wait for them to be started correctly, checking the endpoint health. Through the Kuberete tools, we can see the services that are displayed in each namespace. So, state as production step depend on our configuration. The pipeline, we will wait for a user order, execute the next step. And now we launch the stake state. Before launching the last state, we will have to start the infrastructure services. The service is not logical that you create the pipeline every time, because they are always the same. The Srping Cloud Pipeline has a utility to do this. We execute the utility and we will create all the infrastructure services in the namespace of Kuberete. Finally, we go back to Jenkins and execute the last step. Using the tools of Kuberete, we will be able to see all the services have been started in production correctly. As we have seen, when we combine Srping Cloud Pipeline and Contract, we make our deployment for microservices totally secure and automatic. Pipeline provides a base for automating the flow of the cluster, but also allow us to customize the whole pipeline overwriting the pipeline code. We have also seen that the pipeline is perfectly integrated with the contract, and this means that we could cover all the tests of our microservices. In summary, Srping Cloud Pipeline and Contract together allow automated the whole life cycle of our microservices. Thank you for your attention.